Hello students, welcome to my channel. Today we are going to see the properties of integers. Okay, so what are integers? Integers are nothing but negative numbers. Integers are negative numbers, 0 and positive numbers, right? So integers are the collection of negative numbers, 0 and positive numbers. So already we have seen the first two exercises and review exercise in this chapter. So today we are going to learn the properties. So first one, closure property. So what is closure property means? If we take two integers, first one we can say A and the second one B. If first integer is 1 and the second integer is -2, okay. First, there are four fundamental operations or the basic operations, that is addition, subtraction, multiplication, division. These are all called four basic fundamental operations of mathematics, right? So first we will see additions. In the beginning, in your childhood, in the school, you will learn additions first, right? So now we will see additions. If I add A plus B, what is the value of A? 1, and what's the value of B? -2. So here, whenever we got the both symbols side by side, then we have to subtract. So 1 plus into minus 2. So here both the integers have different signs. Then just subtract small number from big number. 2 minus 1, 1. Then what is the sign before big number? Minus. So it will be -1. Is -1 contains in integers or not? Yes, it is an integer, right? So I took two integers and the sum is also an integer. So I can say integers are closed under addition. That means if A comma B belongs to Z, belongs to means A comma B are integers. That means A comma B contains in integers. Then A plus B also belongs to integers. Then we can say integers are closed under addition. So integers are closed under addition. Next we will see under subtraction. Okay, under subtraction, both here A and B, I am taking same numbers. So A equals to 1 and B equal to -2. Now I am calculating A minus B. So see, A 1 minus of -2. So here I am calculating A minus B. 1 minus of -2. So what is the product of two negative symbols? It is plus only. Already we have learned in multiplication of integers. 1 plus 2 equals to 3. So again we got a positive number, right? This 3 is also in the integers, right? So and so on. There are a lot of negative numbers and there are a lot of positive numbers, but small numbers I am taking just for your understanding. So I took two integers and the subtraction of integers is also an integer. So I can say integers are closed under subtraction, right? If A comma B or integers belongs to Z, then A minus B also belongs to Z. That means integers are closed under subtraction. Okay. So after subtraction, now we will see multiplication. Okay. So in the multiplication, again I am taking A as 1 and B as -2 only. Now I am doing A into B. A into B. So this here A is 1 and B is -2. In the multiplication, if one integer has negative sign, the resultant also negative. So 1 into 2, 2. So here also again minus 2 is also an integer, right? So I took two integers and the product of the two integers is also an integer. So I can say integers are closed under multiplication. So a comma b belongs to z, then a into b is also belongs to z. That means integers are closed under multiplication. And last we will see division. Okay, so division. So a divided by b, 1 divided by minus 2. So in the division of integers, if 1 is negative, then the result also negative. So we have to divide 1 with 2. Okay, excluding the minus sign. Already minus is there here. So 2, 1 is the smallest number here, smaller than 2, right? So put 0 and here also 0. Now 1 became 10. So put decimal point. So how many times 2 divides 10? 5 times. 2 5s are 10. So this is minus 0.5. You check whether right side of 0 there is 1, 2, 3, 4, 5, 6, 7 and so on counting numbers, and left side of 0 negative numbers, right? But is there any number like this 0.5? No. So that means this is not an integer. This is not an integer. So I can say integers are not closed under division. So if a comma b belongs to z, then a divided by b does not belongs to z. That means integers are not closed under division. Okay. So here we have learned the closure property of integers. First of all, if we add two integers, then the result also we are getting integers. So we can say the addition, the sum of integers follows closure property. That means integers are closed under addition. In the same way, if we subtract two integers, we will get again an integer. So we can tell integers are closed under subtraction. In the same way, already we have seen if the product of two integers is also an integer, then we can say integers follow closure property. So integers are closed under multiplication also. But coming to the division, integers are not closed under division. Okay, this is our closure property. Next we will see commutative property. Now we will see the commutative property of integers. So what are integers? Negative numbers and 0 and positive numbers are called integers. Integers are the collection of negative numbers, 0 and positive numbers, right? So the four basic operations in mathematics is addition, subtraction, multiplication, division, right? So we will see commutative property under addition first. I am taking a as 1 and b a as minus 3. Okay, so commutative property means a plus b. First we will calculate a plus b and then we will calculate b plus a. Simply we change the place. The first number goes to the second place and the second place number goes to the first place. Okay, so I am adding a plus b, 1 plus minus 3. So plus into minus minus. So if here in this case we have to subtract small number from big number, 3 minus 1 2, and the sign before big number is minus. So this is minus 2, right? Similarly b plus a, minus 3 plus 1. So here big number is 3, small number is 1. Two numbers have different symbols. So subtract small number from big number, 3 minus 1 2 and minus is there. So minus 2. So if you observe, this a plus b is equal to b plus a. a plus b equal to b plus a. So now we can say integers are commutative under addition. Integers are commutative under addition. So a plus b is equal to b plus a. So if a comma b are integers belongs to z, then a plus b is equal to b plus a. Then we can say integers are commutative under addition. Now we will see under subtraction. Okay. So if a plus b equal to b plus a, we can say integers are commutative under addition. So same under subtraction now we are seeing. So a minus b and b minus a we have to calculate. So a minus b 1, a here 1, a is 1 minus b is minus 3. So 1 minus into minus plus 3, 1 plus 3 4, right? So b minus 3 minus a minus 1, sorry, a 1 only, a 1. So here both the numbers have same symbol, so then we have to add the numbers. 3 plus 1 4, and what is the symbol or sign to both numbers? Minus. So this is minus 4. So is 4 equals to minus 4? No, not equal. So a minus b not equals to b minus a. So we can say integers are not commutative under subtraction. That means integers do not follow commutative property in the subtraction. Okay, but in the addition integers follow. Coming to the subtraction, integers doesn't follow the commutative property. And we see now multiplication, a into b and b into a. Okay students, so now a is 1 and b minus 3. Whenever we are multiplying the integers, we are multiplying two integers. If one is negative, then the answer also negative. 1 3 is a 3. b is minus 3 and a is 1. So the answer will be negative. 3 1s are 3. So minus 3 equals to minus 3, right? So a into b is equal to b into a. So I can say that integers are commutative under multiplication. Okay. So integers follow commutative property in the multiplication. So next we will see under division. So integers follow commutative property under addition. Integers do not follow commutative property under subtraction, and integers follows commutative property under multiplication. Now we will see division. A divided by b and b divided by a. So 1 divided by minus 3. The answer will be minus. We have to divide 1 with 3. So 1 is smaller than 3. So put 0 in the quotient and put 0 after 1. Now 1 will become 10. So put decimal point. 3 3s are 9. The remainder is 1. Again decimal point is there, so we can add another 0. Again 3 3s are 9. So it will continuous like that. So I can write 0.33 and so on. Okay. So b divided by a. Here b is minus 3 divided by 1. When we divide 3 with 1, 1 3s are 3. So the remainder will be 0. So this is minus 1. Is minus 0.3 is equal to minus 1? No, not at all, right? So a divided by b not is equal to b divided by a. So integers are not commutative under division. So integers are not commutative under subtraction, and integers are not commutative under division. Integers are commutative under multiplication, and integers are commutative under multiplication. Integers are commutative under addition. Okay. So commutative property means a plus b is equal to b plus a and a minus b equal to b minus a, but actually a minus b not equals to b minus a. Okay. So I think you understand this commutative property.